Today, we're tackling a massive health, safety, and environment topic: fire risk assessment for the lead-acid battery manufacturing industry. We're going to take what might sometimes feel like a dry compliance checklist and transform it into a dynamic look at the actual life-saving mechanics of industrial safety.
Here is our roadmap for today. We'll be covering 5 sections. 1. The invisible fire threats. 2. People and risk evaluation. 3. The hierarchy of controls. 4. Active fire protection systems. And 5. Emergency planning and review.
But before we jump in, we really need to ask ourselves a foundational question. What invisible elements actually transform a standard, everyday manufacturing floor into a high-stakes explosive environment? Because it's not always the obvious dangers that cause the most devastation.
Section 1. The invisible fire threats.
When you're dealing with lead-acid battery manufacturing, you are going to face 3 major fire hazards. We're talking about hydrogen gas generation, massive electrical hazards, and all that lead dust and combustible material. These 3 elements basically form a highly dangerous triangle that requires constant, vigilant monitoring.
Let's talk about the big one: highly flammable hydrogen gas.
During the charging and formation processes, this gas is constantly being released. Now, the scary part? It's completely invisible. If it builds up in a poorly ventilated area and mixes with the air, it literally creates an explosive mixture where a single spark can cause absolute disaster.
So what sets it off? Well, you've got your obvious ignition sources like open flames and sparks, but you also have electrical faults, short circuits, and equipment that's just running way too hot. And honestly, one of the biggest culprits is just poor housekeeping. Leaving accumulated waste, packaging, or lead oxide powder lying around is basically rolling out the red carpet for a fire to spread rapidly across the floor.
Section 2. People and risk evaluation.
This is where it gets very real, because safety isn't just about protecting the building, it's about the people inside it. Who is actually at risk here? Obviously, your production workers, especially those right up near the charging or chemical lines. But the risk umbrella goes way beyond that. You have to account for maintenance personnel fixing panels, outside contractors, visitors, and of course the emergency response teams who rush into the facility when things go wrong. To properly evaluate all this, we use a risk matrix. It's all about weighing the likelihood of something happening against the severe consequences if it does. For example, how often might poor ventilation or damaged cables occur? And if they do trigger an incident, are we talking about equipment damage, or are we talking about horrific outcomes like toxic exposure, severe burns, or a massive environmental impact?
Section 3. The hierarchy of controls.
Think of this strategy as a fortress with 4 distinct descending walls of strength. The outermost and strongest wall is elimination, literally just removing the waste and unnecessary ignition sources entirely. If you can't do that, you move to engineering controls, like installing heavy-duty ventilation and automatic sprinklers. Wall number 3 is administrative controls, which means strict permit-to-work systems and safety procedures. And finally, step 4 is personal protective equipment, like flame-resistant gear and safety glasses. Notice how PPE is dead last? It's your absolute last line of defense, not your first.
Section 4. Active fire protection systems.
A truly safe facility needs both eyes and muscle. On one hand, you have your fire detection systems, your smoke, heat, and specialized hydrogen gas detectors acting as the early warning network. On the other hand, you have the firefighting equipment, the actual suitable fire extinguishers, hydrant systems, and automatic sprinklers that jump into action to suppress an outbreak.
But here is a massive warning that absolutely cannot be ignored. Water should never be used on energized electrical equipment fires. These battery plants are packed with charging equipment, welding machines, and power panels. Throwing water on a live charging line fire isn't just a mistake, it can be instantly fatal. You always have to use the right extinguishing method for the specific hazard.
Section 5. Emergency planning and review.
Even the most advanced mechanical systems can fail without human readiness. The facility itself must be prepped with clearly marked emergency exits, logical fire evacuation routes, and designated assembly points. But you also need rock-solid emergency communication systems, highly trained fire wardens, and you've got to run regular emergency drills so that the response just becomes pure muscle memory.
And it really comes down to the individual workers too. Every single person on that floor must know exactly how to act when an alarm sounds. They need to know how to raise the alarm themselves, how to evacuate safely without panicking, and how to properly operate the specific fire extinguishers available in their zone. Now keep in mind, a fire risk assessment is not some one-and-done piece of paperwork you just file away on the shelf. Regular audits are mandatory. You absolutely must review and update it after any fire incident, obviously, but also following any process changes, the installation of new equipment, or the introduction of new chemicals or materials. If the facility changes, the safety assessment has to change with it.
At the end of the day, safety starts way before the incident ever happens. Preventing a fire is always better than fighting one. Identifying these hazards before they can spark is the only way to ensure everyone goes home safe. So, I'll leave you with this critical question to think about for your own operations. Are your fire controls still effective today? Take a look around your floor and ask the hard questions. Thanks for joining me on this explainer, and stay safe out